Hey, welcome to Easy Calculus. In this video, I'll be covering partial fractions. Now, let's look at this integral that we have here. So far, we've used techniques such as ln, and we've also used substitution methods just to solve these integrals. We definitely can't use integration by parts because I don't clearly see anything being multiplied. We can't use ln because the derivative of the bottom isn't on the top. We can't use substitution method because nothing's going to cancel no matter what you would pick. So we're left to use this new technique called partial fractions. So the whole point of partial fractions is to just take a fraction like this to second power. Take a fraction like this with its denominator to the second power and somehow break it up into two fractions that are being added together. And each fraction that's being added together is going to have a reduced power in its denominator. So it's going to be easier to solve. And then we'll be able to solve it using our old methods. And we're usually going to end up with either arctan or we're going to end up with ln. Okay, so that's what partial fraction does. So for partial fraction, your denominator has to be something you can factor. So in this case, we can factor this. So we're going to factor it into we're just going to factor it. We're going to get x plus 4 and x plus 2. Yeah. So that's the first step. We've just factored this, and that's a good step. But the only thing is they're still being multiplied. We're trying to get away from multiplication and have them being added up. So for now, I'm just going to focus on this part and just forget about the integral. So I have this, x plus 4 times x plus 2. My goal is to have them being added. So I want something like this. This is what I want. Alright, that's exactly what I want. Because if they're being added, that's going to be a much easier problem to solve than this one here. So I need to somehow pick a numerator so that this is a true statement, so that these two are equal. So it's going to be a mystery numerator. So I'm just going to put a here. I'm going to put b here. For now, I'm just going to tell you just put a and b. After this example, I'm going to go into the whole process of picking your numerators. Alright, so now we need to sort of solve for our old numerator by using our new a and b. So we have to cross multiply. So our common denominator is going to be x plus 4 times x plus 2. So a already has an x plus 4, so it's missing x plus 2. The b is missing x plus 4. So it's going to be 1 equals to a times x plus 2 plus b times x plus 4. So I sort of cross multiplied, but it's more of me just wanting to pick a common denominator. The common denominator has to be this, x plus 4 times x plus 2. So this already has x plus 4. I need to multiply by x plus 2. And the b already has x plus 2. It's missing this one. So that's my new equation that I can solve to find out what a and b is. So now to find out what they are, this is a tricky equation. So what I'm going to do is I'm going to pick a good value for x so that one of these goes away. One of them is 0, so that I can focus on one variable. So a good value for x is going to be -4. Because I want to get a by itself, so I'm going to pick x equals to -4. When I plug in -4 here, this is going to become 0. So I'm going to get 1 equals a times -4 plus 2 plus b times -4 plus 4. So -4 plus 4 is 0, so 0 times b is gone. So I'm left with this. 1 equals a times -4 plus 2, so it's going to be 1 equals to a times -2. Alright, and I can divide both sides by -2, so -1/2 equals to a. So I found out what my a is. Now it's time to get my b. Now to get b, it's going to be the same process. I need to somehow make this a part of the equation go away. So the best number to pick would be -2, because then this part becomes 0, and I'm just left with b. So I'm going to say x equals to -2. So I have 1 equals to a times -2 plus 2 plus b times -2 plus 4. Okay? So now I have 1 equals to a times 0, so this is gone, plus, and it's just going to be b times -2 plus 4, so it's going to be 2 times b. Now divide by 2, so 1/2 equals to b. So now I've concluded and I've found out that my a has to be equal to -1/2, and my b has to be equal to 1/2. Then this is a true statement. Alright, so now this integral is actually equal to, continuing from here, it's actually equal to the integral of a, which is negative 1/2 over x plus 4, plus b, which is 1/2. All I'm doing is just plugging it into this step, over x plus 2 and dx. And the whole thing should be in dx. So this integral is equal to this one. So it looks like it's more complicated because now I have parentheses, I have all these different things. But what I'm going to do is split this up using my integral rules. And so I have negative 1/2 over x plus 4, the integral of that, plus the integral of 1/2 over x plus 2 dx. Okay? Good. And now I'm just going to pull the negative 1/2 to the front and the 1/2 to the front, because those are just constants. I'm just going to do it right here. So it's going to be negative 1/2, and here it's going to be 1/2, and now the numerator is 1. Okay, so now from here, this is familiar territory, because what's the derivative of x plus 4? It's just dx. So the derivative is up top. Same thing over here. What's the derivative of x plus 2? Well, that's just dx. Or you can say 1 dx. So that means this is ln, and this is ln. And if you want to verify it by going through the whole steps, just set x plus 4 to be equal to your u and do u substitution. So now I'm going to be left with this. This is just going to be negative 1/2 ln of x plus 4 plus 1/2 ln of x plus 2 plus c. And that's what my answer is. So let me just recap and show you the steps I did. So first, I started with an equation, and I couldn't do it using any of my methods, but I noticed that I could factor the denominator. I decided to factor it. Now that I've factored it into x plus 4 times x plus 2, I want to break them up so that I have two sums. So in order to do that, I need to choose my denominators. And for now, I just said just put a and b, so I put a and b for my denominators. So not for my numerators, excuse me. It's not always going to be that simple. I'm going to go over how to select the numerators after I finish the example. But I picked a and b, then I said, hey, let me solve for my variables one at a time. Those would be my a and b. And I did that by picking convenient values for x. So here, the convenient value for x is negative 4. Because negative 4 makes this whole right part 0. And I can just follow algebra and find out what a is. Over here, a good value for x is x equals to negative 2. And I can find out what b is doing that, because a just goes away. Then I'm able to directly put them back into what a and b were. Then after that, I've successfully reduced one integral with a denominator to the second power into two separate integrals with denominators to the first power. Then I can use my ln. So from here, this is negative 1/2. From here, I'm able to just get my ln. So it's negative 1/2 ln of x plus 4, 1/2 ln of x plus 2. Okay, so that's how you do it, the partial fractions. Alright, so now let me get more into picking your actual numerators, okay, and your denominators. Okay, let's say I have my integral and I was able to factor it and end up with this right here. Then my new denominator is just going to be the different factors. It's going to be x plus 2 and x plus 3. So now when you're trying to pick the numerators, you've got to look, are my factors linear? If they're linear, then you can just put a, b, then c, then d. You just keep following the alphabet. So here it's just going to become a. This one's going to become b. And if we had another way to factor it, like say at x plus 7, it would be c over x plus 7, and it would just keep going. You just follow the alphabet. And this is the convention that's used with naming them. So that's where we stop for this one. So if it's linear, you can just put a or b. Now in this one, let's say we factored it down to here. Well, we can still factor this, so we shouldn't pick our numerator, so we factor this even more. So this would be x plus 2 and x minus 2. So all my factors is going to be x, then I have x plus 2, and I have x minus 2. And those will be my denominators. I'm going to have x plus 2, x minus 2. So So for my numerators, this is linear, so I can put A. This is also linear, because x is to the first power is what I mean by linear. This is B. This is also linear, so this is C. So as long as it's x to the first power, I can just put the regular alphabet letters. And if I get an equation, if I can reduce it by factoring, then I should factor it. So this is going to be faster, so I need to factor it. Now in this one right here, this is something you call irreducible. It's irreducible because you have a plus sign here, and then this equation has no roots. So this equation is never equal to 0. So this one can't be factored. So what we actually do is, we just take the whole denominator and just write it there. So we're just going to put x squared plus 4. But now because of this, because it's irreducible, for the numerator, we don't just put a, b, c, because this is quadratic, because it's squared. We put ax plus b. So what you do is you put ax, you put a, then an x, and plus the next letter. So after this one, you just keep going. So for this one, I have two irreducible factors. So this is going to be x squared plus 2 plus x squared plus 9. So this is going to be ax plus b for this one. Then for the next one, I'm going to put cx plus d. And then let's say there was another factor, I would put ex plus f. X squared plus 16, whatever it might be. So basically, I'm just following the alphabet for all these examples. So if you have it and it's linear, you can just put A, B, C, A, B, C, D, E, F, G. If it's irreducible, then you need to do something like this. Because if it's a plus, x squared plus something, you need to put like an ax plus b, and then a cx plus d, just follow the alphabet. Okay, so these are the examples we'll be doing. I listed quite a number of them just so that we can get through the different types, because I listed them where they have irreducible factors, where they have reducible factors, where they have repeated factors, also where you end up with ln, you end up with inverse tan, and also where you get like a polynomial to a negative exponent after you integrate. So we're going to go through all of these, and it's a great thing to do if you can just try them on your own before I get to them, or just work them out with me. But after the video is finished, try to do them on your own. If you get stuck, just look back at the video. Alright, so let's get started. Alright, so this is number 2. We already did number 1, and I first have to factor this. So I don't want to think about integrals right now, I just want to think about the fraction itself. So 4 over x squared plus 6x minus 7. I can factor that, and this is going to be x plus 7 and x minus 1. So that's what the denominator is factored. But this isn't good enough. I want it to be two separate sums being added. That way the power of each is reduced. Because here it's x squared, and x squared I can't really solve for now. I need to be doing it when it's just x. So this is going to have to equal to some a over x plus 7 plus x minus 1, and the numerator for that is going to be b. So because my denominators are linear, my two factors, I can just put a and b. Okay? So now I need to solve it. I need to set my old numerator 4 equal to the common denominator. The common denominator is going to be x plus 7 times x minus 1. So it's going to be a times x minus 7, sorry, a times x minus 1 plus b times x plus 7. And that's going to equal to 4. Because I'm trying to, just like with old fractions, like if we had, let's say we had 1/5 and 1/6, common denominator we're going to use is going to be 30. So it's going to be 1 times 5 is going to be 5 plus 1 times 6 to give us 11 over 30. That's sort of what we're doing here. Because we're trying to solve for the old denominator. So it's going to be a times this one plus b times this one. So now I need to solve for my variables one at a time. I want to solve for a first. I'm going to get rid of b. So I got to think about what number is going to make b vanish.